Analyzing quadratic functions, part 1. The purpose of this video, I'm going to walk you through the process of looking at any quadratic function written in standard form, ax squared plus bx plus c equals y or f of x. How do you analyze that function to determine what the graph's going to look like, what the x-intercepts would be, the vertex, those kinds of mathy things. So to begin with, we're going to look at the function y equals x squared plus 10x plus 20. First thing I notice is it's a parabola. The graph is going to be a parabola that opens up. And it seems as though when x is positive, we're going to increase the value. So it's going to be going from wherever the y-axis is, it's going to go up when x is positive, which means it's going to dip to the left. Or using another argument, I could just look at the line. It appears to be the line 10x plus 20, which is a line that looks like this. And then if I was to make a parabola, this is an up parabola, which means I have to take the bottom end of the line and fold it up. And that's how I know we're going to have a dip to the left in this particular parabola. Now, I'm not going to leave you with that crappy graph. Oh, that looks like a funny picture. Let's see if I can make this happen. There we go. Somebody's getting sick. Anyway, I digress. I'm sorry. Let's see. That's what math will do to you. Okay, so get rid of all this stuff. I should have just done the undo button. And I could make the eraser bigger, but it's too late now. It's too late. I'm committed. Okay. So we have the sketch that I just described kind of drawn out. So the first thing I do in my analysis is give evidence that I thought about what the parabola is going to look like. Then I find the axis of symmetry. Actually, I could find the y-intercept. That's the easy point. Given the function, if x equals 0, 0x squared plus, or 0 squared plus 10 times 0 plus 20 equals 20. So I could start off with that. That's shown up in this part of the graph. The graph intersects the y-axis at 20 above the x-axis. Then the axis of symmetry. Formula we worked out, x is the opposite of b divided by 2a. b is the 10, and a is 1. So we're talking about x equals negative 5, the axis of symmetry. So I write all that down. I write the formula down, then I substitute into the formula, then I simplify. 1, 2, 3, easy steps. So that should be reasonable when I look at the axis of symmetry, x equals negative 3. It appears to be a triton. Just kidding. No, it appears to be x is negative is an appropriate value for an axis of symmetry. If I had x is positive 5, that's when I would have to worry. So I feel like I'm on the right track here. Then, to find the vertex, I recognize that the x value of the vertex is already negative 5. So to find the vertex, I simply substitute negative 5 into the function. And I show all my work. For example, negative 5 squared is 25. 10 times negative 5 is negative 50. Add 20. Well, that's interesting. When I put in the axis of symmetry, I find that the value of the middle term is twice as big, only opposite of the first term. I wonder if that's always true at the vertex. Probably not. So then I summarize my findings. First found a y-intercept of 20, and the axis of symmetry at negative 5, causing the vertex to be negative 5. And put all this information together along with a bonus point, which I'll share with you in a moment. The bonus point is negative 10, 20. Because if you go to 0, 20, you go 5 over to the axis of symmetry, you go 5 more, you're at x equals negative 10, and you're right back to the y value you started at. So if the axis of symmetry is negative 5, it will take 10 units to go all the way back to where you started. Call that a bonus point because it makes it easier to graph my parabola. So I label the vertex and the y-intercept and the bonus point, and I could also now make inferences about the x-intercepts. I know I'm going to have two x-intercepts. They're both going to be negative. One of them is going to be really close to maybe negative 2, and the other one probably around negative 7. So then I will do the mathematics later to find those exact values. Just another quick example then. In this function, I see that it's an upward opening parabola that dips down to the right, and it crosses the y-axis down in the negative land. Also, I could make the observation that it's a decreasing line that starts below 0. Either way, I should get the image of the parabola dipping to the right, opening up as shown here. First thing I do then is find a nice and easy free point. If y is 0 squared minus 6 times 0 minus 11, f of 0 is negative 11. Therefore, we have an easy point, a y-intercept, and that's found right here on the graph. Next, I find the axis of symmetry. Look, I write down the formula every time. The opposite of b over 2a ends up being x equals 3. Once again, I'm happy with that result because it makes my triton on the right-hand side, the way I want it to be. And the, oops, I don't need that line. See a line. Oops, I didn't want that to happen. Let's see what happens when I do that. All right, then I know that when x equals 3, we have the we go straight through the vertex. So to find the vertex, I just substitute 3 in for x. F of 3 is negative 20. That's way down below. I'm feeling good about that though, because since the y-intercept is negative 11, it seems like the vertex should be below negative 11, and negative 20 is below negative 11. So that helps me assure that I'm doing the work right. Summarize my findings and get a bonus point if I have to go, as the graph shows. If I have to go 3 to the right, then my symmetry point is going to be 6 away. So if I'm at 0, negative 11, I will also be at 6, negative 11. I label the vertex, I label the bonus point, I label the y-intercept, and I can see now estimates for my x-intercepts are around 7.5 and negative 1.5, both the same distance away from 3. Hope that's helpful.